Hello, we're back. So example 2 talks about a standard deck of playing cards. You have 52 cards in 4 suits, clubs, hearts, diamonds, and spades. When I was growing up in high school, this is what people did. I mean, I didn't, but Mr. Stenning certainly did. And no, we did not go to the same school. Okay, so each suit has 13 cards. I'm not a card player, so you just have to remember all of this information. Each suit has 13 cards, 9 numbered cards, an ace, a jack, a king, and a queen. Complete the chart based on the above information. You've got desired outcomes, okay? Also called an event. So your event is your desired outcomes. So what is the outcome specifically? Well, drawing a king of hearts, the only outcome that you'll be satisfied with is a single card, okay? So the probability of getting a king of hearts is equal to 1 out of 52, okay? Because that's the number of outcomes that will satisfy you, okay? And that's the number of cards in total. Is it a simple event or not? It is a simple event. Simple event because there's exactly one outcome. Only one thing will satisfy, okay? Drawing so basically it's being very specific, okay? So if your event is specific, then chances are it's a simple event. So a simple event is just one outcome, fact of one. Drawing a numbered spade. See how I'm less specific here. Okay, so a numbered spade are the outcomes that include what? An ace, it's a spade, a 2 spade, 3 spade, 4 spade. See how we're counting these now? 5 spade, a 6 spade, 7 spade, an 8 spade. You get the gist. 9 spade, and then there's a 10. Okay, oops. So if we count all of these, right, we would get a total of 10. So the theoretical probability of getting a numbered spade are all 10 divided by the 52, okay? Because there are 10, the number of numbered spades divided by the number of possible outcomes. So we're still using this formula here, right? We're still using that formula, and we'll continue to use that formula. Okay, is it simple or not? Not simple. Not a simple event because there's more than one outcome that will be satisfied with. Right? Okay, drawing an ace, a jack, a king, or a queen. Okay, so this is very broad. It's broad because we can have in hearts, we can have an ace, how am I going to write this? Ace, a jack, a king, or a queen. Right? So we have hearts. Maybe it might make sense if I list them. So hearts, ace, jack, king, queen. Okay, so hearts, and we've said there's 4 suits. So we've got hearts, we've got clubs, okay, we've got diamonds, got an ace, a jack, a king, or a queen. Ace, jack, king, or a queen. And then we've also got spades. So spades, ace, jack, king, queen. Now, if you are already trying to find a shortcut, you might ask yourself, well, what is the pattern here? So we've got 4 suits, right? 4 suits, 1, 2, 3, 4. And each of those 4 suits have 1, 2, 3, 4. So we could say that there's 4 suits times 4 desired outcomes. So that should give us 16. So the probability of an ace, a jack, a king, or a queen is equal to 16 divided by 52. Divide that by 4. 4 out of 13. And that makes sense, right? Because 13 is the number of cards in each suit, and 4 represents the ace, jack, king, or queen. Is it simple? Not simple. Not a simple event because there is more than one event that will be happy with. So it's all about what's in the brackets, right? If it's very specific, right, only one of these will do, it's simple. If it's very general, then it's not simple. Okay, here, so remember I said that it's something it's not, right? So the cookie example would be, this would be like, I want a chocolate chip cookie, not a chocolate chip cookie. See how the questions are identical, except I've just used the word not, okay? So I don't want to list, I mean, that would be absolutely ridiculous. So see what I mean about being a shortcut. This is a shortcut. So the outcomes are anything that isn't in C, right? So it's the hearts, it's cards 2 to 10, it's the clubs, cards 2 to 10. It's the diamonds, numbers 2 to 10, and it's the spades, 2 to 10. Right? I mean, we could, if we wanted to, count those up, right? So you could say, well, that's just the pattern, right? There's 9 here, 9 here, 9 here, 9 here, which, I mean, it's fine. So you'd say it's 4 groups, 1, 2, 3, 4, 4 of 9, which is, you know, it's fine. We could say, though, that, for instance, the probability of a ace, a jack, a king, or queen that's not, right? Probability that's not an ace, a jack, a king, or a queen is equal to 1 minus the probability of getting an ace, a jack, a king, or a queen, right? So 1 is just simply 52 out of 52, okay? And then here it's the 16 out of the 52, right? So we subtract, and what do we get? We get 9 out of 13 if we reduce it. Okay? So that's the difference between this 4 out of 13, right? And the 13 out of 13. Okay, so is it a simple event? No, not a simple event. Since we're happy with more than one outcome. Okay? All right, you're going to do these questions here, and I'll make more space in your handout for your chart.